Lesson, we're going to be talking about acids and bases. We started to discuss them when we were talking about the different types of chemical reactions. So in a neutralization reaction, we take an acid and base and we make a salt and water. So we're going to talk today about what makes something an acid, what makes something a base, what are their properties. So some common acids and bases that we may come across in our everyday life, one of them is citric acid. So citric acid is found in lemons, oranges, any citrus fruit, and it gives it a very tart or sour taste. So here's a structure of that citric acid. Another acid that we may have come across, if you've ever been stung by like a stinging ant before, they actually inject a very weak acid, a formic acid, but it still causes that burning sensation in your skin. Another aspirin that you may have used before was aspirin. So aspirin is actually called acetylsalicylic acid, which structure is here. So again, it's a weak acid. We use it as a medication. Glycerin as well is an amino acid, has both an acid and a basic group on them. But it's found in a lot of beauty products and stuff like that. If you see glycerin on the label, that's what the structure is. Caffeine found in coffee is a weak base. And sea slugs actually excrete a very strong acid, sulfuric acid, which is the same kind of acid found in car batteries. So what is an acid? So an acid is a substance that's going to give us a hydrogen ion when it's dissolved in water. So having that hydrogen out front, like in this one, or ascorbic acid or carboxylic acid, so here you go. See the acid, the hydrogen out front indicates that it's an acid. And when you add it to water, it dissolves and breaks apart and gives that hydrogen ion. So to note if something is an acid, we look for that hydrogen out front. The only one that doesn't really put the hydrogen out front is acetic acid, which is found in vinegar. They put it at the end just because that's where the hydrogen attaches to. So it actually attaches to the oxygen there. But this one is also an acid. So looking for that hydrogen out front indicates a substance is an acid. So a base then is something that's going to form a hydroxide ion when you add it to water. So to note if something is a base, we look for that OH group, and it will usually come second. So like aluminum hydroxide has that OH there, calcium hydroxide, magnesium hydroxide, sodium hydroxide. The only one that doesn't, that we may come across, is ammonia, which is NH3, and that's actually a base used in a lot of cleaners in your households. So let's practice identifying whether we have an acid or a base. So here we have a hydrogen out front. So let's see if we can identify here whether we have an acid or a base. So looking at number 1 here, we have a hydrogen out front, so that indicates that we have an acid. Number 2, we have an OH. So remember, that indicates we have a base. Number 3, again, we have the hydrogen out front, making it an acid. Number 4, hydrogen out front, makes it an acid. Number 5, we have hydroxide, the OH group, so that makes a base. Now remember 6, we don't have a hydrogen out front, but we don't have an OH. So remember, this was our exception to the rule on this one. So this one was actually a base, ammonia. Number 7, hydrogen out front again, making it an acid. Number 8, hydrogen out front again, makes it an acid. Number 9, we have the OH group, making it a base. And finally, number 10, hydrogen out front again, makes it an acid. So looking for that hydrogen group in the front or the OH group at the end will help you determine whether something's an acid or a base. So what are some properties of our different acids and bases? So acids are going to have a sour taste to them. So if you've ever had like a lemon or an orange, it has that sour taste to it. They're going to react with a metal. So like magnesium metal or carbon or copper metal. They're always going to have a pH less than 7. We'll talk more about pH here in a second. They're going to turn litmus paper from blue to red. They will produce hydrogen ions. So remember, indication of an acid is having hydrogen. And it will take an indicator and it will keep it clear. So the indicator we're going to maybe use next week in a lab is phenolphthalein. So it keeps the indicator clear. So it's just a test we can use to determine whether something's an acid or base. Same with the litmus paper. Just a test we could do to see if something's an acid or base. So bases are going to have a bitter taste to them. So if you've ever had like gotten soap in your mouth or something like that, it tastes kind of bitter. Or if you've ever had a Tums, which is an antacid, opposite of an acid is a base, so antacid, it does have a very bitter taste to it. Bases are going to feel soapy or slippery. So soap is an actual base, that's why it feels slippery. They're going to have a pH greater than 7 on the pH scale. They're going to take red litmus paper and turn it blue. Bases always have the OH ion present. And this time they're going to turn the indicator phenolphthalein pink. So again, just another way we can test to see if something is an acid or a base. So maybe you've tasted some of these very sour candies. So they actually coat the candy in an acid, like citric acid or malic acid, to give it that sour taste. But it doesn't last very long. Usually it eventually goes away. So sometimes they add an extra acid like malic acid to make it last longer. And if you have too much of it, you can actually burn your tongue. So acids will burn your skin. Same thing with your tongue. If you have too much of that sour acid on it, it can damage your tongue. So let's talk then about the pH scale. So this is the scale we use to measure if something's an acid or base. So we use like a meter to measure it. It's going to give us a number between 1 to 14. Or we use a little strip of paper. It turns colors, and that color indicates a certain pH, like looking on the scale here. So let's label this scale. So we're going to start at 0. We're going to go to 7 in the middle. So anything between 0 and less than 7 makes it an acid. If we're at 7, we have a neutral solution. And then the top of the scale is 14. So anything greater than 7 up to 14, that's a base. So it's just a scale we use to determine whether something's an acid or a base. So you can see here some examples of things that have different pHs, like drain cleaner is way up here, 14. Ammonia, which is in cleaners and soap, around 10 to 12. Water should be around a pH of 7. Bananas, fruits are kind of 3 to 5. And then you get to lemon or hydrochloric acid, which are very low. So how do we measure pH mathematically? So pH actually stands for the power of the hydrogen ion. So the more hydrogen you have, the more acidic something is. The less hydrogen that you have, the more basic you are. So we use this equation here to calculate the pH of our solution. So we take the concentration of our hydrogen ion, so brackets mean concentration. We take the negative log of that. So we just use our calculator to do that. So we hit negative, we type in the log, and then we would type in the number for how many hydrogens are there. And then we could do the opposite. So let's say we want to know how many hydrogens are in our solution. We take 10 to the power of the negative and then whatever our pH is. So we can go back and forth using both of those equations. So let's try a couple examples. So if we know our concentration of our hydrogen is 0.05, what is our pH? So we're going to take the negative log of 0.05 and type that into our calculator. We get a pH of 1.3. Okay, let's try one more. So the negative log of 5.2 times 10 to the negative 12. plug that into our calculator, we get a pH of 11.3. So we always want to round to 2 decimal places, or to 1 decimal place. And lastly, let's say we know our pH, we want to find our concentration. We're going to take 10 to the power of negative, and then our pH, which is 4 this time. So we plug that into our calculator, we get 1.0 times 10 to the negative 4th. Or your calculator may not write it in scientific notation, it may give you 0.0001. Either one of those are an acceptable answer. So that was how many hydrogens we have in our solution.